Welcome back, everyone, to the Time Horizons podcast, where we talk to the people building the future today.
Yeah, and today we're super excited to be interviewing Shreya Shankar, who's used to work at Viaduct AI as well as interned at Facebook and Google Brain, graduated from her master's at Stanford. She has a really amazing website where she writes some really great blogs that I've had the pleasure of reading, and following her on Twitter has also been really great. And we're super excited to talk to you today, Shreya.
Thanks, and thank you for having me.
Yeah, so just to start off the conversation, why don't you tell us a bit about what you're working on right now?
Right now, I'm not supposed to be working. I'm on a break. I most recently left my job as the first ML engineer at an applied ML startup. I got really interested in the whole idea of ML ops, or essentially tooling for deploying production-grade machine learning models and monitoring them. How do we especially do this at scale? So I've been thinking about that a lot, and hopefully starting a PhD program in the fall. Yeah, to work on this kind of stuff.
Great, yeah, and so I wanted to dive into a bit about, I know you specifically focus on machine learning ops and machine learning systems, and how did you get into that space and that setting, and why did you make that a focus for you?
Yeah, I think it dates back to my interest generally in machine learning research. I did some machine learning research in undergrad, specifically in adversarial examples and robustness. And to me, I was like very interested in pursuing this in a PhD, but it felt weird to me because I had never actually like deployed a machine learning model that does something in industry. And how could I talk about, at least I was under the impression, like, how could I talk about robustness if I don't even know what robustness means in an industry setting? So that kind of motivated me to go work at an applied ML startup and kind of see what the problems were on the table. And it was just very, very different from what I had even expected. Like, it's not really about like adversarial examples from like a minimal norm perturbation setting. We're struggling with things like putting a decision tree in production and like data distribution shift, and what happens after you've trained a model that achieves high accuracy on like a test set. Beyond test set, how do you make sure that it continually delivers high performance? And these are the kinds of questions that came up for me whenever I was building models that actually saved the client's money or something. How do I build tools to kind of make my life easier instead of like, I don't know, using the SHAP library every 3 seconds to like understand like why one example may have been classified the way it was. I don't know.
For sure. And I know that you're doing some work as well with this ML systems seminar coming up as well with the workshop. What is the goal with teaching students about systems? I guess what is the goal there as well?
I don't think I have really planned out an agenda for anything. You know? I think one of the things that I wish I had known when I was doing research in the ML research community is like the importance of software engineering and kind of like what happens after you deploy a model, what happens post research stage. Because I mean, if I had known that, I think I would have designed my research differently. So maybe the goal there, in a sense, is to kind of like give researchers a view into how people use their models post deployment.
Right. That's interesting. So I read the piece on your site, the retrospective you did on predictive modeling. So the impression that I got there is most of the work that you see as like the kind of gating problems to deploying many of these models is really these kind of engineering problems. Like you talked about, it's not so much that you need to use the fanciest model in the world, but it's really about doing the work of, but first of all, figuring out what problem you're trying to solve, and then figuring out how can you actually deploy that model at all, right? Like not
Sure.
how good the model is on metrics. So that would be a good summary, would it?
Yes, I think there's multiple points to that. When I reduce it to engineering problems, it gives off this vibe that like, oh, like we can do engineering problems, like industry will solve them. I want to caveat that these are unsolved engineering problems that are the reasons why ML models fail in production. Like, for example, how do you quantify semantically the data distribution shift? Like for example, if I'm Uber, last week's rides are very obviously different from this week's rides, but are they semantically or meaningfully different? And how do you like apply these kinds of statistical tests at scale? Maybe stats is like solve this. I don't know, but it's not clear to me in terms of like talking to other data scientists or really working on these problems in industry that people have come up with really good ways of measuring this.
Yeah, so that's really interesting that the there doesn't seem to be the metrics to be able to quantify these types of issues. Do you think there's a reason why that gets worked on less than, for example, the latest nth iteration of the transformer model or any of these things in academia? Because it seems like these problems should have a lot of like economic value, and so in some sense should be getting solved. Like, why do you think that is?
Yeah, for sure. There's probably a lot of reasons. One is I think just doing this kind of production ML at scale, it's fairly new. Like Spark, for example, really came about in most recent years, and it's probably one of the most popular ways to manipulate large data sets in industry right now. So we've just only recently gotten the tools and technologies to be able to kind of work with this pretty seamlessly at scale, especially data scientists who are like not used to try to like work on distributed systems, for example. So I think that's part of it. I lost my train of thought. I'm sorry. What was the thing? Oh, instead of working on research. Another thing I think with research is historically researchers, especially in ML, have kind of worked on fixed data sets where like somebody cleans and presents a data set to you and you like are optimizing for something. And when the data set is not changing, like why would it ever occur to somebody to like work on what happens when the data set changes?
So do you think that's a like just a rights issue, or is it like a cultural issue? Because obviously, like if you are working in an academic setting, you don't necessarily have the data set that Uber has, and thus you don't encounter the same problems. So yeah, that's a really interesting point that you made. Yeah.
And Arthur, I would almost think about also the growing community of open science and like how people are trying to push for more public data, like groups like the Lacuna Fund out of Google pushing for these more open science data sets. And I wonder how that might translate now into the research community when we start to see the growing community of people considering more about ethics, bias in data, especially in 2020, and how that might be coming into play this year. I wonder what your thoughts are on how did your mindset shift when you went from academia to industry with respect to ethics and bias when deploying a model that has the ability to touch the lives of real people?
Yeah, for sure. I became pretty convinced that, okay, this is just an opinion, but we shouldn't be using ML to make decisions about people's lives, such as like loan prediction or any like forecasting of like decisions that like actually impact humans and like whatever decisions that they want on a day-to-day basis. I feel like it's just why would you do that? But maybe that's just my opinion. In terms of ethics and fairness specifically, I worked a little bit on fairness research in my undergrad, and whenever going to industry, I think this was just because of the stage of the startup I was in, like super early stage. It wasn't like at utmost concern to like be fair to all of our users because we were training like individual models for each client, for example. And the other thing is some of our clients wanted to be somewhat unfair to their clients. Like they will have their own clients that they want to prioritize more and they want to make sure the model works really, really well for, because those are the, I guess, second level clients that like pay them the most money. I don't know. So a lot of this fairness stuff, I think, is very domain specific in a way that I feel like I just can't really comment on for other domains because I don't have experience in those. But I did change my mind a lot on transparency and interpretability. When I was in undergrad, like doing research and listening to people's talks, I think there was this like one pretty famous debate at some like NeurIPS conference with like Jan LeCun and like Bean Kim talking about like interpretability and is it necessary? And whenever I got to industry, I found myself really, really wanting interpretability as a way to like just verify that my model was doing something sane. Because the thing was like in industry, it's like I'll build a model and it'll achieve some performance. And I'll want to know like, okay, is this like out of a fluke or is this legitimate? Like, what are the top features? For example, if the top features don't make any sense, then this is a fluke. And furthermore, like I want this interpretability so I know how to iterate on the model. Like if the top features don't include something that I think is important, or like a subject matter expert thinks is important, then like great, like that's another idea. Maybe we upweight that feature. I don't know. So I really found myself thinking of interpretability as like a must-have for data scientists or ML practitioners to just iterate on their own models.
Yeah. So in your article, you touched on this as well. You talked about the Google Translate issue, which like was brought up years ago as like those bias in the way it does translations, like it will insert gender where there is none, and so on. I'm curious to know, do you think that something like Google Translate, like, do you think, first of all, should it have, obviously, like, it's bad to have bias, right? But should they have put it out there without having done all of these tests? Or is it okay? And, you know, once a service becomes big enough, society will figure out all these issues and it will adapt over time. So, like, I'm just interested to know what your take is on that side of things.
For sure. I think ideally, yes, you should do as much like robustness checks as you can before you, especially with a language model, before you release like a language model. I think the reality is that you can do all the checks in the world, but like I don't think when Google like released this version of, I don't know, like Seek to Seek or whatever it was before Transformers, I don't think that they knew that this was a problem. Maybe they did, but I find it really hard to believe that they like really sat there and like tested gender neutral languages. But I think that points to the broader thing of there are always going to be things that we miss. And the like you can't like wait to deploy a model until like you got everything checked off, because there's inevitably going to be something you missed.
Well, so like just kind of, so what's the difference between the Google Translate example and before you were saying like we shouldn't use ML in decisions that impact people's lives? So like where do you think is the line there? Just see what I'm asking.
Very good point. I think for things like loan prediction, like recidivism, prison recidivism, crimes, like things that are just
right. They're directly making a very impactful decision versus Google Translate. If it messes up the translation, you know, it's not great, but no one's being.
It's still bad. It's still bad. I don't want to like say like, oh, this is like acceptable. I just want to highlight that I think it's completely unacceptable to make a decision whether somebody should go to jail or not, or whether someone should be hired or not based on like, I don't know, their race or like their zip code or proxies for things that they just cannot control.
For sure. And I guess a follow-up question that I have is, you know, there was a paper that came out in December. I might be butchering the title of it, but it was something to do with oxidative pulse checking that New England Journal published about how individuals of color were performing worse on who needed to be admitted to the hospital. And this is something not unique to December of 2020 in a health case that's been shown in other settings as well. But we also know that balancing a data set might not actually solve the problem as well, with individual researchers like, for people who are listening, Timnit Gebru and Joy Buluani's paper, Gender Shades, highlights that even if we balance the data set, it won't work. So how do we make progress, not technically speaking, but more so like socially, with making sure that we can still iterate these models in the real world without maybe having the data set be balanced, and with these still metrics like calibration, fairness, and privacy that we're continuing to improve upon?
I cannot answer your question. I'm so sorry. I feel so underqualified compared to like anybody who's actually done research in this area to be able to answer that question. I will say that like I got pretty interested in like the distributionally robust optimization literature for just like what does it mean to kind of like define subpopulations, and then like build like acceptance criteria for how good the model should be for each subpopulation. But I don't know if this is like a great approach at all. I feel like resort to the literature, talking to somebody who thinks about this space 24/7. Yeah,
for sure. Yeah, and I wanted to go back as well to some of the, you know, the machine learning for ops setting. I guess as undergrads who also listen to this podcast and more often than not are promoted to take a lot of theory-based classes in undergrad, and really hone in on the theory and the skills to make these deep tech contributions. But it almost seems like I'd just be curious to know what you think about finding that happy balance between I can actually do something versus I can solve math. And yeah, like
Yeah, I think that's interesting. I also think that every program or university does this differently. Like for example, Stanford, uh, it is very good at churning out people who've trained 100 neural networks in their undergrad. And other schools might be very good at churning out students who can solve like convex optimization problems in their sleep. I don't know. I think every school like, has their own thing that they really hammer to their students. I will say that I don't think that this is a great, or sorry, this is a something of concern. Like I found that whenever I went to industry, there were a lot of unknown unknowns. Like I didn't really understand anything about. I didn't even know that there was like an ops for ML. I didn't even know what it meant to do like infrastructure for ML, and I was able to learn that on whether it's like talking to people fine. Like I was able to understand like, okay, like how do you set up a Kubernetes cluster, and like how do you deploy a machine learning app, and how do you serve that, and kind of like all of these things that are not taught in undergrad and I don't think need to. I will say the thing that really helped me is I did my undergrad in systems, and I think that these concepts just come up like all the time. um like maybe I can't prove the convexity of something as quickly as like somebody else using some like hack, but I feel like I can like understand how I was able to understand how like Spark performance tuning can be helpful, like stuff like that. It's always a trade-off, and when you go into industry, like you'll find yourself like super annoyed at the thing that you know the most, which is not generalizable to everyone. Like when I was in industry, I always found myself like, oh, I like wish that I was better at stats, or like I wish that I was better at like math. And I know like coworkers and other people who say things like, oh, I wish I was better at like parallel computing, or like understanding like how I could make this faster. And I just like never came up to me because that's all I did in my undergrad. So it just depends for everyone.
Yeah, actually, I think that that's definitely really relatable for me as well. Just like you always wish you had the skill that you don't have.
Yeah.
And yeah,
Yeah.
no, for sure. And I wanted to, I guess, when your work right now, I wanted to try to get a better sense of what are you targeting towards, I guess, in terms of your objective within ML ops, or whether it is ML ops or not.
Totally.
Where are you moving towards?
Yeah, I'm not 100% sure. I think that there's a lot of open problems in ML ops, like ranging from like the data distribution shift that I was talking about to just like even like collaboration issues for like when you deploy a model, how do you streamline the feedback process so that a client or like a PM or a non-technical person can like debug the pipeline? Because right now software has figured that out. You can
Right.
like file a ticket or like file a bug, and like some engineer will get to it and like close it, and it's great. Nobody knows how to do this in ML except for the data scientists, and it's like it's such a pain, right? Like imagine if you were the single person responsible for like fielding everything. It's just no. So I think there's a lot of low hanging fruit, but there's at least like 300 tools in the space, which is like a lot of bloat. I will say that I'm more interested by like the whole implications on like database innovations that these problems have. So for example, like if we're to build like common abstractions for some of these problems, like maybe these are like different kinds of databases that have the solutions, like different requirements, stuff like that. So I think that's why that was what motivated me to apply to PhD programs, and hopefully get a chance to spend a lot of time thinking of the right solutions there.
Yeah, so it sounds like you're really interested in this kind of systems approach to things. I definitely, like personally, having like thought a lot about kind of the history of like technological progress and innovation. It definitely seems like when people go back and try and change the fundamentals, it's often different to what people are focusing on. But that's where the real like progress comes, right? Because it's great if you can get a slightly better accuracy score on some pre-baked data set, but if you can make the data scientist 10 times more productive and maybe actually get some machine learning model being used in the real world, then that actually could have a lot more value.
Yeah, totally. I was reading the statistic the other day from I think like some Gartner thing, but they were saying like 55% of companies who are actively developed ML have never deployed a single model, which is like unbelievable to me. If researchers knew like why is somebody trying to eke out 0.2% performance boost on ImageNet when like this is really where we're at, right? I don't know.
Yeah,
And
different sets of problems.
I guess in industry, how do we guide people from the research community to also start thinking about more pressing problems than like we comment on here, like just getting 2% better or whatever, 0.2% better on their existing model, but might be thinking about problems they're not thinking about. How to apply this into different settings like climate, equitable healthcare, education. And I think there's some work being done to reform machine learning. I know the Reform ML workshop at iClear is trying to think about this as well. What are your thoughts on how to incentivize the academic industry to making maybe what the work that they're doing more applicable to more pressing problems?
Yeah, I have a lot. I thought about this a lot because I am going to go to grad school. I think a big issue is the publication incentive in ML. There's way too many conferences. It is literally normal now for people to have 5 papers a year. And I think that like looking at PhD
some
admissions,
some a lot more.
yeah, like it's just crazy. Looking at PhD admissions this year, I was like looking at like profiles of like, okay, like who am I competing against? And I was like, oh my God, like this person has like 7 first author papers at like ACL, or just unbelievable, right? And
but none of
to
those
me,
papers are often very innovative, right? Like, quality definitely does drop for sure as you
maybe I don't know. I feel like I can't comment on it because I like haven't read all of these papers. But I do think like incentive wise, I really like the systems community and like several systems labs for this idea, but it's essentially a lot of systems labs will have like specific projects that are going on and then like write papers incrementally and build out these software projects, and especially like work with like the HCI department or whatnot to conduct like user studies on how people use this, what are the next things to build, how do we make them more efficient. Whereas in the ML community, it really feels like this like kitchen sink approach, as well as like every paper that I write, I'm going to release a separate code base, which is just like I don't know how that.
You have to get those GitHub
scales.
stores.
Yeah, I don't know how that scales, and like incentive wise, right? I don't think people are incentivized to solve the most pressing problems because it is legitimately feasible to like write a NeurIPS paper in 3 weeks, which is crazy to me. But yeah, just my opinion.
It feels almost like we're trying to, like it goes back to even one of the blogs you wrote, AI saviorism, which is like the thought that AI can help. It's not true, but the I guess false perception that it's going to solve all of our problems, when in fact the people who are making the most or trying to make the most progress in these tools don't have the right incentivized systems to actually apply it to those types of settings in the first place. So it is
100%. I wonder if like there's only one conference every 2 years or only like journals. I feel like everybody's mindsets would just be like, oh, like what do I work on? Everyone would just be like they would be having an identity crisis. Like there aren't 4 deadlines a year for you to work towards.
It's almost like, I mean, you could almost draw it to sports in some setting where it's like the Olympics are so high quality and so high.
Sure.
You have the highest performing athletes who are truly the best at what they do because it's so spaced out. There's not a race every single weekend where you can just get a participation medal and put that up on your wall and have this fake artificial wall of medals where here I'm working towards this one medal 4 years from now, and it's more honest to the system, right?
Well. I also think that a lot of people, but the flip side is I think a lot of people would not be doing ML. Maybe that's a good thing. I don't know. Maybe it's oversaturated at this point.
And I guess there's also this new, I mean, I recently came across it. Maybe it's not as new as I thought it was, but it's the ML-Sys research is like at the intersection of that. And I'm wondering if you could speak a bit towards that. And I guess that's what you're probably going to be encountering in your PhD, I'd assume as well.
I would imagine. I think ML-Sys, like at least when I looked at the proceedings for the past several years, it feels very catch-all for like both ML systems and systems for ML. Like, oh, let me apply ML to like do scheduling and operating systems better, like something like that. So I want to caveat like my interests are very much like systems for people to build relevant production grade machine learning models and deploy them. I am not as interested in like optimizing process scheduling or like better page faulting mechanisms. Or I don't know, whatever.
Yeah, so
people come up
in
with.
terms of like that kind of bridge then between like the problem and kind of the solution, how do you find that works with experts, for example, in particular domains? Like if you're trying to build a model um, for some business, right? The business is doing something,
Yeah.
hopefully. And so how does that interface work? And how could it be improved? Do you think more machine learning
Yeah.
people need to get more domain specific knowledge, or they just need to get better at communicating? Or is there not a problem? Is it like very kind of good right now? So
Yeah, I don't think it's good right now. I think it took me a while. I worked on applied ML for cars, so like predicting when components of cars will fail. I know nothing about cars. I couldn't care less about cars. Um, but it took me several months to realize I need a domain expert to really like help me, like something like, oh, like a crankshaft failure. I shouldn't be like throwing every possible bit of data at like a random forest and seeing what happens. Like a lot of these like features or the indicators of failure are going to be like um, features that neural networks could never learn, like specific combinations or like specific like oh, like if your horsepower is like super or your like sustained power is super high or something, like all these things I just wouldn't even know. And I think like that's where I had to learn how to communicate with somebody who's like a mechanical engineer, like understands cars. I don't think that there's any like formalized mechanisms for this. Like the way that I kind of did it was explain like, here's a problem that I'm trying to solve, and like it is significantly easier for and faster for me to come to like some sort of working prototype of a model if you like explain to me like what are indicators that you look for in a broken crankshaft, and like um how would you figure that out like 3 months in advance if you were to look at the sensor data. What is the transformation, or you don't ask them what the transformation is, but you like figure out how to code up that transformation of the sensors. But yeah.
I was also wondering, I guess you commented earlier on some of the biggest problems in industry being, how do we deal with data distribution shift? How do we deal with not making the data science be the be all and end all of solving problems, but making it more explainable for people who play other roles that maybe aren't as technical? But what do you think is the biggest problems that people aren't working on, but maybe know that exist in the system right now and just aren't being tapped into for some reason in ML
Yeah.
systems?
Well, I think a lot of people are working on it, but just not doing it the right way. I think there's lacking or how do I explain this? Like a GitHub for machine learning workflows specifically. Like imagine software development without GitHub or CI/CD. Like how would people collaborate on code bases? Uh, like how it just
yeah,
wouldn't work. And I think that's where we're at in machine learning. Like there's no concept of versioning. There's no concept of like collaboration and like deployments and like testing and like CI/CD. And reality is that most of these companies like they use GitHub, but code for machine learning is only like one small part of the workflow, right? There's like data, hyperparameters, all of these other things. And so every company ends up building their own like little version of whatever CI/CD management tool for machine learning, and they're all like built poorly because I mean that's what happens if every company tried to invent Git from scratch. It wouldn't be useful. So in a way, I think like that is really what's lacking. But I don't think this is unknown. I think this is very well known, but it is quite a hard problem to it would be quite an engineering feat to like solve this in a very like user friendly setting to where anybody could use it.
Right. And it feels as though there's definitely a tool for each and every single aspect out there. It's just a culmination of them. You've got
Yeah,
the
where's the GitHub?
international
Yeah.
buffet someone could ask for, but all the right restaurants are there. And it's like, yeah, no, I could agree with that. It would be nice to have that. And I guess,
Yeah, but like how do you even think about that? How do you build that in the right abstraction? I mean, a lot of this is
yeah,
you can see the problem, but you cannot see the solution. Otherwise, somebody would have built it.
for sure, for sure. And I guess if I'm understanding your story as well a bit, you went into systems because I know you commented on in one of your stories, there's like 1,000 people doing deep learning or machine learning in like another class or whatever it was. How
Yeah.
has conformism played in a bit into your life of like, there's 1,000
Mm.
people doing that. How am I going to be helpful? in that space, or maybe you thought I could be helpful in that space, but I'm interested in something else. How's conformity played a role in the way you think about where you want to put your time?
Yeah, I have this like big sense of FOMO, so in a way, conformity like guides me towards actually understanding what the hell is going on. Like deep learning, for example, like I was like, oh, I like have to do something in deep, or I have to like take a deep learning class so that way I like don't miss out. I don't know if this is like a principle everybody should embody. I just think it's like a flaw of mine that I have FOMO. But in terms of systems specifically, I reflect on this a lot, and I think it's why I went to systems, a combination of many reasons. One being I think I went and I took a deep learning class first, and I realized that people are just they're just like I like could not understand like all this amount of code going on. Like it just doesn't seem organized to me. It's very my first experience with deep learning was it is so easy to get everything running, but have 0% accuracy or like just it doesn't work, but there are no compiler or runtime errors. And to me, I was like, this is stupid. Like, you should be able to have compiler and runtime. Like, anytime I like built a system or like some, I don't know, like if it works, it works. There's no like fake
Yeah.
working. There's no like NumPy broadcasting crap that's going on, or like I don't
Yeah.
know,
For
like all of
sure,
these things.
definitely. And it definitely seems like with machine learning, you can have like you're saying, like if the model doesn't work, but even if the model does work, you can still have 0%, like you might not even have confidence that it's working
Yeah,
as expected.
yeah,
Like
exactly.
like like for example, in your piece, right, you mentioned that you were making this model and one of the features was the labels, and you only discovered that because you went back into the data and realized that. But how many models have gone into production like that? Who knows, right? Like
Yeah,
yeah.
it's just wild.
Yeah, but do you think it's possible to like test these kinds of things better? Because like um because it's so numerical, right? Like there's a lot of things going on that aren't as easy to test as does this function rearrange
Yeah.
this string well, or does it allocate memory correctly? Like, or is it just people being lazy and it really actually isn't
No,
that difficult?
I don't think it's people being lazy. I think that machine learning as a field has kind of well, I think it's important to understand like ML researchers and data science workflows, which is like a rapid iteration on an
Mm-hmm.
architecture or something until you get something that you want.
Mm-hmm.
And like from a programming language perspective, like if you want something that gives you such rapid iteration like that, you want something that's like not typed. You want a scripting language. You want something that's probably interpreted in some way. Like
Yeah.
it makes sense that Python was chosen, and or like a lot of people are converging to Julia also for similar reasons.
Yeah.
It makes total sense. Whereas when in like software and system, traditional software and system building, right, people will like sit down for a week, spec it out, think about it critically, and then like just go code it up. And like, of course, they'll run into bugs, but it is not that like super. The nature is not super high
Yeah.
iteration like a data scientist would do.
But the data
Um,
scientist isn't able to do that planning ahead of time, right? Because they don't necessarily know what's going to work. Like there's kind of an
exactly,
alchemy there that happens during that notebook
hundred
process.
percent. Yeah,
And
I very much so. And like this is why I don't think this is why I'm a big fan of notebooks, actually, even though they have a lot of problems. I think they're the perfect tool for such a high iteration job. And
yeah.
um it's this kind of like
I think my internet has cut out. One second.
Frozen.
Hello?
Oh, you're back.
Yes,
yeah,
yes,
you're back.
I'm sorry, my internet cut out for a second.
No, you're back. You're back.
Yeah.
Yeah. No, I find it really interesting as well. I think developing these types of skills are definitely something you just don't encounter in school whatsoever. It's something you have to put yourself in even a lab setting. Are you really like incentivized to encounter these types of problems? Not really. Like we talked about before, you're just kind of being pushed to get the next conference paper out and then move on to the next conference, et cetera, et cetera. And I guess what do you think maybe, and I don't know if you agree with that, maybe it's different at Stanford than it is at University of Toronto, but it seems like analogous across students. And from my POV, I guess, what have you seen being either the biggest, if you think, do you think school is really good, or do you think school can improve upon improving people? And like, you're
Yeah.
going into a PhD recognizing, I guess, the problems that exist within it. And I think many people do. What's motivating you to still go in to do that PhD?
The main reason I think that I want to get a PhD is like I want a large amount of time to think about the right solutions to problems. Like if I'm at a startup, I have to like make money now. And a lot of it's just like quickly building solutions and like just letting them go and then like working on the next thing that will make the money. And that bothers my like personality. I want to have a lot of time to think about the right way to do things and also generalize to other applications. In terms of like universities, what was your exact question?
I guess like, did school prepare you for any like beyond like for life, I guess, per se? And like, like I think
that's fair.
in undergrad
I
people
think
contemplate it all the time.
Yeah, I think the answer is no, but I would be hard pressed to find a school that does prepare you for life. And I also don't think that you need to like learn all the skills that you would like learn in the real world. You couldn't learn them in your job. Like I think like big tech companies, software engineers are like famous for this. Like Facebook has like a 6-week boot camp in which like you could probably walk into Facebook like only knowing like, I don't know, basic recursion and like be a successful software engineer because they literally train you how to be a Facebook software engineer, right? You don't need a 4-year undergrad for this. But I think so. My take on undergrad would be like use it to like just, I don't know, enjoy yourself, learn about what you like, learn about your own working styles. Like I think that was something that really helped me when I was in industry. Like things like, oh, I can't pull all-nighters. This is like not for me, sort of thing. So just like, I don't know, maturing as a human being. But I think that is really what college is for. It's not going to teach you anything like extremely relevant, right? I think it just kind of teaches you what you like.
For sure. Yeah, I think everyone does get caught up. And I think I'm not like a historian or anything, but if I'm correct, like education systems were brought from like philosophy to learn abstract things, and like it was more seen as like, I'm not learning the labor jobs. And then it evolved to today where, you still aren't necessarily learning the very hands-on technical stuff.
That's fine. You can learn them pretty easily.
Yeah. And that's why they have things like boot camps, like Lambda School and other types of programs for that type of, rapid technical learning, I guess, as well.
Yeah. But I don't think college is useless. I think college is a great place. I became a human being. Like I went from like a kid to an adult there, and I don't think you can kind of have that transition in such an environment in other places.
And in school, I guess there's this growing community. Like I call it the productivity porn community, which is like people who just talk about, I have my Kanban board for today. I'm going to be productive. Like, what are your thoughts on this growing community of people?
Well, yeah, whatever helps them sleep at night, I guess. I don't know.
Yeah.
No, nobody cares. I think to each their own. Like.
Yeah.
It really just speaks to FOMO. People are obsessed with it because they have FOMO.
For sure.
But yeah.
Yeah. I think it's something that people get caught up in very easily with. Who's doing the most per day? Who's not doing work? Who didn't publish? It's all these different types of things, and it's getting crazy. It almost feels like undergrad community is getting more competitive itself. Like, why do undergrads have to publish 3 to 5 papers in their undergrad to get into a master's? And it is pretty crazy.
Yeah, I think that speaks to just this like nature of too many conferences and ML. Like, yeah, I don't know. My dream would be to do a PhD and not publish more than a couple of ML papers, but who knows what will happen? I don't know. Maybe my future employer will listen to this and like rescind my offer position. I don't know.
For sure. And I guess what's another thing you just outside of ML ops, outside of technical work day in day, what's another thing you've been thinking about but just haven't had the time to work on because it's not, I guess, something you've put your time into in the past? Like, what's something you've been thinking about that you want to see other people, if not yourself, be doing?
Yeah, I think a lot about like mental health and designing specifically from a clinical point of view, like designing solutions or tools to help people with diagnosed mental illnesses. be more effective in their day-to-day lives. Like, for example, a lot of concern in like bipolar and borderline people is to like maintain some sort of emotional stability. So how do you quantify that? How do you compute that without the like user having to really actively think about it? A lot of the problems that I see in these kinds of like therapy sessions or whatever, therapy is great, but it requires you to self-report how you feel. Like, how am I feeling right now? You're obviously biased by literally how you feel right now. So kind of like, how do you unbias that as much as possible and figure out how to like quantify progress in a way, all of these kinds of things, but also like abstracting this kind of solution away from the user so that the user doesn't have to like look at dashboards of like all their activity and stuff like that. It's just alerting them whenever they're unstable or something like that, like designing a solution that helps them keep distance from themselves in some way. So yeah, I don't know. I think there's like a lot of interesting like low-hanging fruit in terms of like, we as humans produce so much data. Like, I text a bunch of people and I send a lot of text messages every day, and you could probably assess my mental state just based on that. And then you can come up with technical problems like, how do you do this in a privacy preserving way? How do you do this without machine learning? Because like the last thing you want to do is like have an auto encoder for each human. Like, why would anyone want this? It's just, yeah, I think there's like a whole treasure trove of problems you could think about in that area.
For sure. Yeah, I think that's something I've been also thinking about with the amount of wearable data that's used in sports as well, is like it's burdensome on the athlete to report to the coach how their mental health is. It is biased because I'm, even dieting apps have the same problem. Like, when I don't put food in, the missingness is like the most valuable information for them to know I cheated. Like,
yeah, exactly.
So yeah, I think there's a lot of definitely low-hanging fruit, as you say, in that space that could be really, really interesting. Arthur, do you have any other high-level questions?
I think one question we're trying to ask on every podcast now is, what do you understand about the world, about yourself, about like just like society in general? What do you understand better than anybody else?
Oh.
You can take a minute to think about that.
Nothing. I don't know. There's no way I understand anything better than anyone else.
Okay,
except for what it's like to be myself.
Yeah. Okay. Yeah. That makes sense.
Yeah.
But yeah. Sorry.
Go ahead.
Oh no, I was just going to say like, I guess you have all these insights into like, machine learning systems and that kind of thing. What, like, do you think that those insights are like unique? Because it definitely is like stuff that you don't necessarily come across every day. So how did you, was it just basically happenstance of experience, or yeah, like how did you come up with those? Yeah,
I think it's just experience. And yeah, I'm lucky to have a diverse range of experience. I'm lucky to have made a very big transition from research to industry, like a very pronounced one in which I was writing papers every day. I was not writing papers every day. And that was probably really helpful. But I think it's like, it's not just one thing, right? It's like, also I had a wonderful undergraduate education. I am the kind of very reflective person. There's like a lot of things that like kind of like make this fall together. I'm very interested by technical problems. I don't like being at a large company because I feel like I could just disappear and no one would notice. Like a lot of these things.
That's interesting. Yeah, because actually one thing I did want to ask earlier, that I didn't get a chance, was you said you don't like being at a large company, but it seems like the problem that you're interested in solving, right? Like this kind of making the GitHub for machine learning, or like, at least building pieces of that. That's the type of thing that if you're in, Google research or something, you could try and build out. So why do you feel that that's not a good way of doing it?
Yeah, let me rephrase that. I think I just don't want to go into a large company as a like entry level engineer, like right out of undergrad, because the reality is like there are thousands of other people that are just like me, and I end up just like getting thrown out a problem and I could be replaced by the next new grad. I think it's probably very different to like go after some experience and like know exactly what I want to work on or be hired into a specific role. I think it was just for me that I learned in my internship. I was like, why am I here? There's probably somebody who's like clamoring over to get a Facebook internship and could literally do the same thing that I'm doing. Like there are those interns that like live in the office from like 8 a.m. to like midnight, and I did not want to be in the office. It just felt like, I don't know, I was taking a spot from somebody who would have wanted it more, and enjoyed it more.
Yeah, that's
But
really interesting
yeah.
because it seems you value not just doing something that's replaceable, and I can really relate to that. Like I'm always trying to figure out how can I do something like unique that someone else isn't just going to come in and replace me. Like, yeah, I really like
Uh,
that framing.
Back
yeah,
to
but
the
the
sorry.
thing to keep in mind there is like I spent a lot of time struggling with that, and there are a lot of people I think that could do what I do. It's not hard. The thing that makes it unique is like I am actually interested and passionate about what I do, and like there are a lot of people who can write code in their sleep, but they like couldn't care less about it. And that's all you need, right, to distinguish yourself, is to like find something that you're interested in working on every day for a long period of time.
Yeah, for sure. Getting that fulfillment beyond whatever
Yeah.
the traditional, I guess, conformist means even is. I guess what else are you looking forward to in 2021? So you commented, I guess, a bit earlier that you got a triathlon coming up. What else?
Yeah.
I mean, I guess it's probably a hectic time for you right now as well with PhD applications, I guess, coming back. I'd imagine at this time.
Yeah, so I'm looking forward to that. I've heard back from some places and not others, so I think I just have to like wait for visit days to be over and then figure out where I'll go. So that's it. I'm looking forward to that. I also feel incredibly grateful. I feel like if I had applied next year, maybe I wouldn't have gotten anywhere. You never know with these things. Um, yeah, I don't know. It's a pandemic. There's like not much to.
Yeah.
This in itself is a lot.
Has there been any like key lessons for you from the pandemic that you think has been instrumental in the way you approach problems, activities, or anything?
Oh, yeah. I mean, I didn't quite realize this when I graduated, but I feel like most grads, when they go to industry, or like I would say like graduate their PhD or undergrad or master's and they go to industry, like 2 to 3 years into their job, they have this like big existential crisis. I've seen this literally for every single person that I know. They're like, am I working on something relevant? Like, I don't want to be at a cog in the wheel. Or if they were at a startup, they were like, like I could imagine going to Facebook and being a software engineer and like trying to like justify it to themselves. And like all of these people will have this existential crisis, or they'll be like, I want to switch into a different role, or like I want to, oh, this is my favorite one, I want to work on climate. So like let me go to like a high paid, like let me go to Tesla.
Yeah, Shreya has this crisis for himself about every 2 weeks that he wants to work in climate suddenly. Yeah.
And then they like go like but then they're like, I want to make a lot of money, so let me go to Tesla because I believe in like electric vehicles because that's good for the climate. I literally just like random like existential crises, and I think the pandemic just like accelerated that for a lot of people.
Yeah.
Which is like, I'm very grateful. Like I would rather know earlier that I want to get a PhD than later.
Sure.
Yeah.
It's exciting though. I'm excited to see wherever you do. I've loved following your Twitter, and I'd recommend anyone out there to follow it. It's pretty fun and enjoyable as well. And your blogs are always really, really good to. I think everyone's pushing. It seems like blogs and podcasts definitely have been like a spur of the moment in the pandemic, and more people are pushing out.
Yeah.
I mean, we did too with this podcast, but I think,
Sure.
but like even blogs, like very few are high quality and feel like people put time into, and I really do enjoy reading your blogs. It feels like time was put in for sure.
Yeah, I don't know what I'll write next or when I'll post something, but I mean, I don't think I feel like I wrote a very big thing recently, and so many people were like, "Oh, this is great," and in my head, I'm like, "You didn't read the whole thing, did you?" Like, like maybe I'll just wait for people to read the whole thing before I write the next thing. I don't know.
Anticipation, yeah, for sure. And did you have any? I guess, and Arthur, if you have any other questions before I ask for like last.
Nope. You can.
Yeah. Did you have anything else you want to say to our audience, which is primarily like an undergrad and occasional parent or whatever it is listening to the podcast of these students who like need to learn more about why I should or should not go into this field?
Oh no! Oh my God, that's sad.
This podcast. But yeah, do you have anything else you want to say?
No, I mean, what do I wish I'd known? Sleep 8 hours a day. Like, it's caught up to me now. I need to sleep 8 to 9 hours a day. Otherwise, like I'm like a monster if I don't sleep 8 to 9 hours every day. And I think that was because I spent a lot of time in high school and college getting less than 6 hours of sleep.
So I'll tell you something really brief here. I got this device called the Whoop. I don't know if you've heard of the Whoop device.
No.
It's a wearable data, like another wearable device where you focus on getting information about your sleep. And for the audience, I made it a goal for 2021 that I want to be in the top 1% of efficient sleepers in the world. And like Whoop has these like categories of like from the time you go to bed to the time you wake up, optimize your sleep. And it's been super good for like triathlon as well as just for like work and school. So yeah, I also can agree with those sentiments.
Yeah, if you don't sleep now, it'll catch up whenever you're old. Like the last thing you want to do is spend 10 hours sleeping every day in your 20s. That sucks.
For sure. And we'll be sure to put your Twitter and your blog in the show notes, and if there's anything else, we'll be sure to put it in the show notes for links and everything. So we really appreciate everyone for taking the time to listen today and connect with on Shreya's Twitter, as well as follow Time Horizons podcast on Twitter as well. So thanks everyone.
Thanks.